up to 1,000 degrees and sometimes up to 1,300 degrees. And that needs to be taken into account when you see these videos. Okay, I'm not an expert, and this is just some of the types of batteries that we will see in EV cars, for example. And what you have here is you have the cylindrical, you have the spout, and you have the prismatic. Now, depending on the vehicle manufacturer, there can be the different types, different vehicle manufacturers using the different types. And what you basically have is, you have a battery cell pack, which might be a number of the, let's say the cylindrical. They're put together into a module, and then a certain number of modules are then put in to create a battery management system. And that basically is the energy that you have for vehicles to run on the traction drive. I'm being very basic on this, but I'm just giving you a very quick overview of the EV. There's only 4 main areas I've looked at there. And basically you have the onboard charger, which is your plug-in at the side of the car. You have what's called HV, high voltage, low voltage, DC to DC converter, which takes into account, and it's bidirectional, and what that is doing, it takes into account the different energies that are coming from either a domestic charger used for your cars, if you bought an EV car, and also for the more the larger areas, the public areas, like on motorways where you'll have an EV car charger. That's much more powerful and it charges up much more quicker. So we take that into account. The second one is the BMS, that is your battery management system. And then finally you have what's called an inverter, and that takes the direct current and converts it to AC to run the traction drive. That's my expertise on that, but I just thought I'd put you a picture. So, EV cars are the future, and you can see from there that we have a growth rate. So the latest growth rate in 2021 was 178 billion was spent on cars. They reckon by 2030 there'll be 1,108 billion. So we're going in the right direction. We are building lots and lots of cars. And it'll get to the point that when you go to car parks, there'll be more EV cars than there actually will be internal combustion engine cars. But the graph on the right actually is just giving you an indication that this has come from the UK, that the number of fires that they've had in electric, they represent 20% are scooters and 40% are cars. So they take the biggest part of the pie there in terms of what's going on. So we'll have a look at that. And what you see there is a range of cars. There's all sorts of cars there. And the two differences are you've got a BEV, which is a battery electric vehicle, and you've got a PH, which is a plug-in hybrid electric vehicle. So that's just giving you an overview of what they are there. So we talked about lithium batteries, and we can see there are absolutely other uses for these lithium batteries. And they are, it's a great technology, I'm not taking that away, it's fantastic technology to put this energy. So we have them in the scooters, we have them in our laptops, we have them in our iPads, we have them in our domestic garages, because this is the way forward, for systems. And we also have the manufactured battery energy storage systems that are starting to be built in different parts of the world and the country. So, what generally, I wouldn't say it's everything, but I'm giving you the overall, what generally causes these battery fires? And when you look to the left, basically, damage to lithium batteries could be in a road traffic accident. It could be, when you see scooters up and down the roads, when they get really good, they start bunny hopping, and they're hitting the curb, and they're well balanced, and they can go over them very quickly. That would cause damage eventually to these vehicles, to the scooters. There could be mechanical damage. Something could impinge underneath the car or into one of the battery chargers of a scooter, and then that will start this thermal runaway that you may see. It could be overloaded. Again, what we need to look at, or incorrect charging. They put the wrong charger into the system. These are things that have caused fires to go either in the car or from the charger itself. Very important one, the quality of the workmanship. There's standards out there of batteries and battery chargers, and there's also makes and models that maybe are not as good and do damage very quickly. So we have to be reticent of that. And then the thermal load can be affected by extreme heat or extreme cold. So there's various factors. We don't know they're not the full gambit there, but there's a number that will come through from the fire reports that we received. And as you can see there, a thermal run rate is basically a chemical process. Once the battery has been impinged, whatever reason or damage, it creates a short circuit. That short circuit then starts to generate heat, and that generated heat then increases the temperature, which passes then onto the next battery and onto the next one, and it's a very rapid process once it starts. And it is incumbent on the actual amount of energy that's in the battery at the time. In other words, if it's fully charged, you're going to get a much more powerful reaction than you will if it's less charged, around 30%. And I'll show you that on a graph. So, let's just have a look at this one. You can see there, this is the thermal runaway. Straight away, it's conflagrated. It looks like it's in a confined space. So what's happened is, the vapour came out very quickly to whatever reason, and then it quickly ignited. So take that into account when we're thinking about the firefighters approaching this, and even yourselves if you're trying to use an extinguisher. You're just going to be thinking on an EV car vehicle. On this one, now this is being charged by this particular battery charger. Again, you can see the trailing leads. This probably isn't to a good standard, but what you see now is, again, it's the thermal runaway coming from the car, and watch in a minute where you'll see it flaming, and it's like a flame torch. And what happens here is it gets so intense that it starts to melt the wing mirror of the truck next to it. You'll see it drip in a second. There you go, you see it go there. So, both of them are showing quite a very fast reaction. Now, this is very interesting. What you're seeing here is how the vapor cloud, what's going to happen is going to explode. You've got heavier than air and lighter than air vapor coming out this, and that is based on the components within the battery. So you can see it went along the floor and it's along the top, and then it exploded. Okay? Again, that was inside a building. It had windows, but that was inside a building. Now I just want you to see the scooter on, and that, when you see all this, you'll begin to see how dangerous, and what ESL were talking about earlier was the fact that these are now being in your premises, in your house, or in your apartment, or in the corridor, the means of escape of the apartment block, and sometimes in the hallway. And it's starting to kill people. It just catches fire immediately. He tries to put it out. Unfortunately, he panics and he slips in a minute. But watch what happens next. Now it starts shooting out. So you can see here by these batteries, there's a lot of rapid lateral spread of fire, which will take us into the thinking of car packs as well. This is one more, and why I put this on here is, before I came out last week, this happened in my local area. A person died from non-serious injuries after e-bike causes devastating house blaze. So we've actually had death from this in the UK, and we're starting to really think about these now more and more. So on this one, what you see, it pops. There you go, wakes the dog up. Now watch how fast this goes. He unplugs it. So this is what we're dealing with these types of lithium batteries. So you've seen the vapor, you've seen what it can do. Now let's just talk about what it is. And this is what is in the white vapor cloud. Hydrogen, carbon monoxide, carbon dioxide, hydrogen fluoride, hydrogen chloride, hydrogen cyanide, So what we're saying here we've got an explosive material mixture as well as a poisonous toxic mixture. So when these things are happening, who approaches it? You know, we want to protect our firefighters here as well. So this is an emerging risk that we're seeing. But again, how do you deal with this if it's in your house with a scooter? We've really got to be thinking about that. And there are some things out there, I wouldn't say it's got everything, but we'll talk about that. So, just to recap, we've seen what they can do. We've seen how they can react in confined spaces. You're more likely to get a vapor cloud explosion. Let's start talking about out there now, what's happening, what's really happening for the fire services. So, I took this was an EV that caught fire. Now, for the fire authorities around the world, it was difficult to extinguish, and this case study said it suggested 150,000 litres for a car. It's hard to understand, but this is what we got. In the UK, now, and maybe I see a couple of colleagues in here, it's now becoming a protracted incident. In other words, when you turn out to a car, and this happened, I believe, in Liverpool, a car caught fire on a driveway of somebody's home, and then what happened was that the appliances had to stay in attendance, I think it was for at least 36 to 48 hours, because they couldn't put the battery out, they could not put it out. Don't forget, it's underneath as well, but the energy in there was continuing to burn. Fire service ops, their stand operating procedures are starting to think about a 50 to 100 metre safety program. That could affect you depending on where it is in a building, let's say, or in a commercial space. One thing I have learned from this is when EV cars are put in, let's say, in promotional areas or in showrooms inside shopping malls, then what happens is a master technician has to come out and he disengages the traction drive. He has to do that because you could inadvertently press the vehicle and it moves forward. That takes a master technician. No one else can do that. You can't just switch it off yourself. So, what that means is, if it catches fire, don't forget the battery is full of energy. You might have disconnected the traction drive because, here's the point, they have to drive it in to the showroom or to the location, so it's fully charged. So, if it's in that condition, you are not going to be able to move the car. And then put that into context of being in some shopping mall or somewhere where you can't move it, and it's now destroying the car itself and the building and the infrastructure, and you've got a fire brigade that has to turn up and try and put it out with tons of water. So if you don't get it out initially, if you don't get fire damage, then it could actually get water damage because of the amount of water. But there are good initiatives out there. This is a great initiative. This also probably helps water runoff and the environment. But here we have an EV containment unit, and what happens is it does not flood the vehicle. What it does is it puts it in and it cools the battery from underneath as well, because it might just be an overheated car like that. I've seen some more draconian ones where they just took a skip and like immersed it completely in and would destroy the car anyway. Also, when we talk about not just EV cars, we talk about the lithium batteries in your iPads. We decided to purchase these bags because what we can do is, if it starts to overheat, we can put it into this fire-rated bag and it will protect it or at least stop the spread. Because there's a perfect example, that picture below is from the fuselage of an aircraft, which again, I just put in very recently because it happened on an aircraft in Asia. I can't actually remember which one. The lithium battery caught fire, and there's your white vapour. After that, it turned into flame after that. So it's important. And you've got to ask the questions, what do you do? You know, your normal extinguisher won't put it out. You need to start to make up special extinguishers and be able to contain the actual lithium battery. And here's another one. Again, it's not all fire services in the UK are carrying these, but this is called a fire shell. And this is basically a very large fire blanket, and it can be pulled over by the fire service and it will trap in and it will hold the water, it will hold the smoke and the fire and the heat especially if you don't have enough water, or maybe you don't, your limited water supplies. This might be an option. I think it'll work. Let me just see. You see how it's actually containing it. I'm not saying it's going to completely cut down the temperature, but it will assist, especially if you're at a roadside and you don't have those water supplies with you. This could be an option. Again, these are all options. Again, another safety measure, another control measure that I've spotted on the market, and I've just brought into the PowerPoint. This emergency plug, this is an amazing piece of kit. Basically, when you turn up, or I used to turn up to road traffic collisions, you try to make the vehicle safe. You chop the vehicle wheels, and you still do those things. But what this does is, it's a universal plug that if you plug it into your charger, it tells the car, intelligently tells the car that it's in charging mode, and it automatically puts the car into parking or neutral. Depends on the make, I couldn't tell you which one. But apparently you can use it for other things as well. So it's just giving another safety factor. It's not the be-all and end-all, it's another safety factor that could be used. But also, you have a car like this involved in a road traffic accident. There's no thermal runaway at this moment in time. You may have somebody trapped in there, but the thing that you've got to remember is that car could be fully charged and that battery is fully charged. So there is a risk of thermal runaway. I think what we've got to be careful for our firefighters is that where we cut into these cars, because if we impinge on the actual lithium battery cells itself, we could have a vapor cloud explosion, or we could certainly have a thermal reaction and have a fire. So it just needs to be there. Now, I put on there an emergency shutdown. All these cars, in some makes and models, and they all vary, so I'm not going to tell you which one, they have a shut-off that actually disconnects the power from the battery to the rest of the vehicle. Doesn't dissipate the energy, it just disconnects, and they're all different, and they're all in different areas. But once you do that, you can't do anything with the car again anyway. But those emergency features are on all these EV cars, but in different locations. I couldn't tell you exactly. But we have to be careful about putting in to cars like this. So this is a whole new learning for fire authorities turning out to road traffic accidents where they have to use the cutting gear. Now, I've mentioned this only because that I'm trying to establish about running fires. Now, an EV car in a location might require lots of water. Now, in the UK, we don't have sprinklers in our side ventilation car parks. But even if we did have sprinklers, I'm not sure how well it would control the fire. Because if you have an EV car, the sprinkler system will only do what the car does when it's raining. It protects it, the fire's underneath, and there could certainly be a spread to the next car. And then what happens is you take a standard car catching fire, and then you might get the fuel running from that normal vehicle. And that's basically what happened here. It wasn't an EV car that started this fire, it was a normal internal combustion engine, but it was a running fuel fire. And if you've got the same problems with an EV, you might have an EV on fire that's next to an ICE, an internal combustion engine car, and it might just start this spread and this conflagration. So we really need to think about that. So, how is it impacting? People are starting to pick up on this. I wouldn't say it's all out there, we've got all the solutions to the right design, because we don't. But I just threw a few of them up there, especially NFPA 13 and 88. NFPA 2022, they changed their car parks from an oil hazard 1 to an oil hazard group 2. So they start to recognise the dangers of car parks. Also, FM Global updated their categories from a category hazard category 2 to a 3 for car parks. They start to think about what is going on, how we start to think about where we put these chargers for cars. Just recently in the news, they're starting to think about it. In the UK, there was a shopping complex being built, and there was space for 160 odd cars. And what we did was, it wasn't approved because the spaces for the cars, they want to put battery chargers in the basement. Now, and it hasn't been approved. Now, the question is, and this is an analogy, would you consider putting a petrol or a diesel pump in your basement? Probably not. So if we are going to have chargers in new building designs, new standard designs, we need to think about the area of fire compensation, smoke control, early detection, and these are things that need to be thought through. Again, what we see here is these are the types of, and there's many on the market, but these are the types of chargers. You get the level 1, which is the one that you have in your domestic premises, and then you go up to level 2, level 3, which is supercharged. So if you stopped at a petrol station on a motorway, you would charge up on one of them. And I've just put in there a couple of guides, and all these guides, everything I've spoke about, is at the back of the presentation. But they're just giving you some guidance, some standards that you may be able to work to. Because the biggest problem, I think what we're going to be seeing today is standard car parks that we have right now, where you're starting to retrofit EV chargers. And I really think you need to look at it carefully where you place these chargers. And if you've got the adequate supplies there, as it says there, good automatic fire suppression, adequate ventilation or smoke control, or depends what it is, access for the firefighters, adequate water supply, the barriers to protect these chargers so nobody hits them, good CCTV monitoring may be an option, automatic, and definitely automatic shuts-off. You need to be able to let the fire service or whoever is in that building be able to do an isolation switch and turn off those battery chargers if they are involved. You need to think about a mechanism of removing the cars. You need to think about that because you won't be able to move these cars. And is this good separation from, say, where the car park is and to the actual main building? Because you could lose, like the car park you saw earlier, you could have a serious damage to your stock. This is interesting. This was work done by Larson and et al. In 2014. I'm not going to do too much about this, but what it says, you can see the high peak of the black line. And what it is they took a number of cells and they generate the heat release. And what it says is when the car is at 100% state of charge, in other words, it's fully charged up, you get roughly around that. That could be debatable, different guidance, different documents, but roughly about 50 kilowatts per the actual short, small battery pack. However, when the state of charge is dropped to 75%, so the battery's only charged to 75%, there is a massive drop in the heat release rate. So there's quite clearly tangible evidence there to suggest that the lower the charge, the less of the heat release rate that will occur. And then at the end. And finally, what you see there is, you're seeing, let's say there's an EV car on a promotion. It's either going to be in an atria that doesn't have any sprinkler system, it might have some smoke control system. But I asked the question, if that catches fire, first of all, how are we going to deal with it? How much water is going to be spilled into that area if the fire brigade or the fire authorities do get there to deal with the incident? If you can't deal with it, you can't put it out, then you could have serious damage to the infrastructure and have to shut down your mall or part of your mall. So the potential risks are the EV car's traction is disengaged, so you won't be able to move it. Location of EV promotions tend to be in non-sprinkled areas like atria. The fire service might have to attend up to 48 hours, so you're going to have the fire service cordoning off the area. So thinking about your business continuity, you need to consider this. You're going to have large quantities of water, possible damage to your infrastructure, possible shutdown of a mall or a concourse let's say in an airport, and then you've got a huge loss in your financial, economical. So there could be, these are just some solutions. Consider putting places cars like that on a plinth that are like castaways that can move very quickly out. Locate them close to an exit so they can get out straight away before they damage your building. Try and make sure they're under sprinklers. Prepare a robust salvage plan. Seriously. Consider limiting the damage to infrastructure through separating or compartmentation. It might be an area you can deem to use for the EV cars. Or, and certainly carry out a fire risk assessment, and if not, if you can get a dummy car to go in there, then that'd be great. But what I've seen, it's not cost effective for the vehicle owners to do that, so it's not something that I expect to see. But that removes the risk completely. And we always say on a fire risk assessment, if you can remove the risk, then get the risk out. So finally, just some recommendations. Review your current installation of all your EV chargers. Are they the right ones? Are they in the right place? And are they fit for purpose? Plus, are they able, if you have an incident there, are you going to be able to deal with it? I think fire authorities, even in the UK, are starting to emerge and see these risks. We're developing new standard operating procedures for dealing with lithium-ion batteries, not just in EV cars, but also in domestic and in general battery energy storage systems, because they're very large and we need to review what we do, our standard operating procedures in terms of that. Review your water supplies, review if the current firefighting equipment is suitable. Do we have the right equipment to deal with it? There's new stuff on the market all the time from America and such like, but we need to look at that. Definitely consider EV chargers at the design stage of any new development. For all the fire consultants in here, there's lots of developments going on in the UAE and the Middle East, we know that, but you've really got to start thinking about what the future is going to hold for these cars. When you're designing the car park, for example, you have to think that EV cars are going to take over from the ICE vehicles. You need to start thinking about within your design spec how well you can protect the building from the car park with whatever provisions, smoke control, fire strategy, whatever you want to use to consider that. Definitely, you need to carry out a risk assessment. Certainly, if you've got cars now, or in any shopping malls or concourse, if you've got a shopping, then you definitely need to have a fire risk assessment and look how safe is it, and look at your business continuity plan. Because if it goes up, you might have a problem. And that's, from me, I put plenty of resources on there, so you can have a look there. I don't mind to look from. And that is it. Thank you.
Thank you, Michael. So those are some very impactful videos that you showed today, and I'm sure there's a lot of questions